Hello guys, welcome to my YouTube channel. So today we'll be solving problem third of Leetcode Biweekly contest 113. So please pause the video, read the question and then we will continue. Okay. So the question is you are given a 2D integer array coordinates and an integer k where coordinates I represents xy and that is the ith coordinate. Basically there's a 2D plane where we know each coordinates have a number x and y representing its x coordinate and y coordinate. So basically we have a 2D integer array representing those points. Now we have one more integer k, and what we need to find out, yeah, there's one more thing that we define the distance between 2 points x1 comma y1 and x2 comma y2 as x1 or x2 and y plus y2 y1 or y2. Okay, so basically this XOR is not, nothing else, just a bitwise operator. XOR, bitwise XOR. Okay, now what we need to return is the number of pairs I and j such that these pairs will be in this coordinate 2D integer array. Okay, so basically I should be less than j and the distance between I and j equals to k. So basically what the question is, just a second. Yeah. So what the question is saying that we will be given a 2D integer array, so x1 comma y1, something like that, x2 comma y2 comma x3 comma y3, sorry, okay, something like that. Okay, now what we need to return is number of pairs I comma j such that xi XOR, let's represent the symbol as XOR, so xi XOR xj plus yi XOR yz equals to k. So we need to return this many pairs and there's one condition, I should be less than j. Okay, so we need to return how many pairs are there such that we can form such a pair whose XOR of x coordinate plus XOR of y coordinate equals to k. So we need to return that many, the number of such pairs. Now, if we'll see on the constraints, because sorry, so if we'll see on the constraint, the size of coordinates, basically the 2D integer array, will be around 10 to the power 5. So the very first or naive approach we could have said is like we could have run a loop like for int I equals to 0, I less than coordinates, let's say cor dot size, or let's say it can be noted as n as well, and I plus plus, let's consider, and then we can run another nested loop j equals to I plus 1, and then j less than, let's say coordinate dot size is represented as n, then j plus plus. So in this scenario, we can run a nested loop and we can simply find the all number of pairs we have. But as we see that n can be up to 10 to the power 5, right? 10 to the power 5. So here, if we will run two loops, then we will have a solution of O n square, which will be O of 10 to the power 10, around 10 to the power 10. So which is not going to be accepted. Okay. So now we need to think of a better solution. Now, if we'll go on the constraint, you will see that it is mentioned that k is only 100. Okay, now how can we use this information? Like if you'll also see the x and y is 10 to the power 6, so it's not looking like very useful. But if k is such a small constraint, that means we can use k. Okay, so now how can we use k? So what the question had said is if xi XOR xj. So like let's say we have selected two coordinates xi comma j. Now I have x coordinate xi and y coordinate yi. Similarly, j have xj comma yj. So this should be the sum of these two XOR values should be equal to k. That was question demands. Now we know that k can be at max 100. Okay, k can be at max 100. So let's keep this thing in mind. Now, what we can say is, let's say if this is some s, or let's say it is denoted by a, that XOR value of xi XOR xj equals to a, then this must be k minus a. Okay. Okay. So I am repeating once again. What I am saying is, we know that xi or xj plus yi or yj equals to k, where k at max can be 100. Now let's consider xi or yi, sorry, xi xi or y xj equals to a. Okay, what I'm saying is xi or xj equals to a. This is the value. Then if we want this condition to be true, that means yi yi or yj should be equals to k minus a. Okay, so what I'm saying that if you want this condition to be true, that means if xi or xj equals to a, then yi or yj should be equals to k minus a. Or in other terms, what we can write from here, let's say if we take xor with a on both the side. Okay, sorry, not with j, my mistake, sorry. Let's take xor with xi or xj. Let's say I am taking xor with xj. It's j, xj. Okay, xj. So what will happen here? Here what is happening is this and this will cancel out, because we know that for any number m, if we take its XOR with m, it will be 0. Okay, and any number with 0, like 0 XOR any number x equals to x. Okay, so that's what we are using over here. If we are taking XOR with both the numbers, then what will this happen? XOR and XOR will be cancelled, and this will become a XOR xj. Okay, and in this left hand side we will only have xi left. I'll just change the pen. So we will have only xi left, and xor, sorry, xj and xj will be cancelled out. Similarly, if we take xor with yj, and in this side also, if we take xor with yj, then what we will have, this yj and this yj will be cancelled out, and we'll have yi. So from this two equation, what we have is xi is equals to a xor xj, and yi is equals to k minus, sorry, here it will be k minus a xor yj. That's what we got from these two equations. Okay, now what we have now, if we'll see that initially what we are trying to do was xi or xj, xi or xj, and there I can be like 0 to n minus 1 basically, and j can be also like on the order of 0 to n minus 1. Basically it will start one from 1 2 3 and something like that. So in total, if we'll run a loop on both of these two, then we'll have to run a loop of o of n square. But now if we'll see that this a, what I said, that we already know k should be less than equal to 100 and greater than equal to 0. Now we know that this a was nothing but a part of k. That's what we decided now. At this place is what we said, the XOR of this xi or xj is equals to a. So that means a can also be at max k. Yeah, because XOR cannot be negative over here. So x can be at max 100 and at min 0. So that means this number can be from 0 to 100. And now here j can go from 0 to n minus 1. So in total our time complexity, so at max here 100, or in for a particular k it will be k. Okay, so like a can be at max k. So what we have is k multiplied by n. Now our time complexity is reduced to big O of k into n. And if we'll see, and now this is of the order 10 to the power 2, and this is of the order 10 to the power 5. So in total it will be of the order 10 to the power 7, and that is totally acceptable solution. Okay, I hope this part you got it all clear. Now coming to the implementation, what we have right now, let's move to that. So we have xi is equals to a or xj, and yi equals to, sorry, here it will be k minus a or yj, it will be yj. Now we just for here it will be j. Now for now what we can say that for every j, for let's say for every j, we need to find the count of such number whose value is xi comma yi. For this particular j, we have to find the number of pairs whose value is exactly xi comma yi. So what we can do is, first of all, we can keep a count. Keep a count. How we can keep a count? By making an map, let's say, of pair int comma int, and let's name it MP. So what MP will do? MP will store the count of particular pair for any pair xy. How many times that particular pair is occurring, that we can store in MP. Okay. Now what we can do is, we can simply iterate over, like we can simply, first of all, we know that we a can be 0 to k. So first of all, what we can do is, we can run a loop something like this: a equals to 0, a less than equals to k, a plus plus, and inside that, what we can do, we can run another loop for j equals to 0, j less than n, and j plus plus. And now we know that, and we can have one variable answer. Initially it will be 0, it will be 0. Okay. And then what we can write over here is if. So, or basically before checking it, let's say new x or xi. What will be xi over here? We know that xi will be equal to a or x of j. Okay. And x of j can be written over here. Let's say we have named the 2D integer as a core. So it can be written as core of j comma core of j0. Similarly, we can have yi. We can name anything. It's not necessary yi, or simply x and y will be suffice. And here it should be k minus a xor core of j comma 1. Okay. And now what we need to do is, first of all, we can simply here we can add our count. So answer plus is equals to map of x comma y. Okay. And now we can close our solution. But there is a one big condition we have missed. What we have missed? We are not checking if I is less than j or not. So how we are going to solve this? So let's say if there are five numbers 0, 1, 2, 3, 4, and if we can take 1, 0 and 3, 0 and 2, that means if we would have considered 0, then we have 2 and 3 as solution. And when we have considered 2, then we have 0 as one solution. And if we have 3, then 0 of one, so 0 is as one solution. Now for 0, we would have added 2 to our answer, and for 2 we would have added 1 to our answer, and for 3 as well we would have added 1 to our answer. That means the solutions are getting repeated exactly twice. So for every I and j, if there is a pair, that means for I we are considering j, and when this is becoming j, we are considering I. That means from our total answer, we need to divide it exactly by 2. So that means we'll have to answer equals to answer by 2. Okay. Now there is one more case that is missing over here. Let's say, let's say, so here we are not removing one case, that is I equals to I. That case is still included. Now, if I is equals to I, that means xi xor will be with xi plus yi xor with yr will be xored with yi, and this will also be 0 because xor of same number is equals to 0, so it will be 0. So now we only need to check if k equals to 0, then only we need to remove this solution or I equals to I. Else, we don't need to worry about this. So if k equals to 0, then only this I and I solution would be counted in our total answer. So now there are n numbers, that means we have calculated for like 0 will be considered with 0, 1 would have been considered with 1. So in total there will be n pairs. So from answer we can simply subtract minus n, or answer is equals to answer minus n, to just exclude the pairs made with self. Okay, self pairs, so like I paired with I, so that we have to remove. That's why we are subtracting n over here, and this is only in the case of k equals to 0, because in other cases we don't need to worry about, because if we take same numbers, then it's going to return its XOR sum or distance equals to 0 only. So if k is not equal to 0, that means we are not counting this in our solution. So first we will subtract this, and then we will move to answer divided equal to answer by 2. I'll just walk through solution. Okay, so first of all, what we did, we made a map for storing count of pairs. Okay, so map of pair L is defined as long long. Okay, so long long, and so we have this map for storing the count. Now what we did was we calculated for each I. Yeah, for now here we have seen that. Yeah, so for running this loop for each A, we are calculating xy and storing. Sorry, first of all we calculated and stored the count. Okay, now then for each number, for each coordinated, for each coordinate we are just creating one A is here j equivalent to j. Okay, so we are just creating new x and new y, and then we are checking if that exists in the map. Here I am using find function, because if the key won't be existing in map, then it will add a key, and sometimes it might lead to tn. That's why I'm better checking it. Okay, so and then I am just I am just adding the count to my answer, and again if k equals to 0, I am subtracting the total numbers, like, or the size of this coordinates array, and finally I am dividing the answer by 2. Okay, let's submit the solution. Cool, it's an easy solution. Let me know if you guys have any doubt in the solution. Thank you guys.